Hello guys, welcome back. In this video, let's talk about how we can make our RAG application better. I have created so many videos in the past, but I'm just showing you, let's say, the simple applications or simple RAG applications without tweaking the components inside it. So my aim in this video is, by the way, TLDR, for those of you who think that there is going to be some code implementation. There is no code implementation in this video. I'm just sharing my ideas how you can make a simple RAG application better in the first half of the video. And in the second half of the video, let's say I will show you or point you towards the links or the documents from where you can get more information to get or to make your RAG application even better. Let's get started. I hope you have already seen this picture in many places, and in my videos also I have shared this many times, right? Let's go step by step what you can do to make your RAG application better, right? First thing first, let's start on this left corner. I will just draw the first diagram, or I will point you here first. So this is the things first, right? Let's say the example here is of the PDF, but you can take this as any documents. So you have a document. First thing first is you need to extract the information. In this case, this is the pages of that PDF, and you need to make or split it into different chunks, right? Before splitting into different chunks, the first part here is how to read that particular document. I have seen most of you asking in my RAG videos. Okay, I have shown you the example of PDF. You were asking how to deal with text files and how to deal with CSVs and so on, right? Those are the things that you need to explore based on your use case. Okay, what is the loader that you can use in order to extract the information out of that particular document, right? That is the first step that you need to explore, because creating a good application in the production is not that easy as me showing you in a simple RAG video, because I'm just showing you, or let's say showing you how to do things, but you need to do your bit of research in order to make it robust. That is the extracting part, and there is the chunking part, right? This is the overlapping thing here. Now you need to split that into different chunks. For that also, in langchain, let's take the example of langchain, you have different ways how to do that into different chunks, right? You can play around with the numbers, and that is also again your choice or how you want to do it, because sometimes the 500 chunk and the chunk overlap of 20 works better for some applications. For some applications it can be 2000 and 100 and so on. So you need to also play around with this number. Okay, what is the best chunk size for your document, right? And after that comes the embedding part. Let me highlight this part now. So what is this? Again, there are many embedding models. Some are open source and some are closed source. So you need to be also experimenting with different embedding models. Okay, which one performs the best, right? The main part here in RAG applications is the embeddings, right? You have a text or document and you want to convert that into the vectors so that the machine understand it and we can perform some kind of semantic sorts into it. So better the embedding model, better the vector embeddings, let's say, because the embeddings also has different or let's say different, or it has, yeah, let's say different token limits. It has different context, right? Some of them, let's say dimensions in a way, easier way, because this ADA from OpenAI has 1536, similar to other they have 512 or something. I will show you in the later half of the video different embedding models and which you can choose out of those. But these are the things that you need to consider. Okay, which embedding models to use? I just want to raise this question because in my previous video of nomic embed text, you were asking, okay, why is it better than ADA? Why is it not better? Why is it so fast and so on? Like, for those things, you need to do a little bit of research yourself and go and compare two different models by yourself, and you can see the difference. Just instead of listening from others only, if you just go and practice yourself, that makes you, okay, doing by yourself makes you better, let's put in that way. And once that is done, now comes the vector storing part. right? I will just highlight now this part of the diagram here. And once you do the embeddings, you have the embeddings, that is the vector embeddings, and you need to store that somewhere, right? And there are many vector databases out there, and there are databases, or you can even do without the databases also, right? You just build the semantic index and use it. But as you can see here, I have written here store embeddings into the semantic index and build semantic index that becomes your knowledge base. And the example here is Pinecone, Fias, Chroma DB. This is the previous diagram I have taken, but now there is quadrant and many things. I might create a video about quadrant also in the future, because that is the one that many people are talking right now. And now, just to point out here also, you need to experiment with different let's say vector databases. One thing that you need to notice here is also that in the vector databases, different vector databases uses different algorithms, and they have their own unique way of storing the embeddings. So they store the embeddings, and also, as I have mentioned here, what is stored here, the embeddings and the document chunks, meaning that they will be storing the context also along with it, and the metadata, for example the document ID, the index, so that you can search between the embeddings in the right, let's say, embedding that is already being stored in the vector database, right? So choosing the right embedding model as well as the right vector database is also what you need to consider. Now let us go to this user part, right? I will just go to this part now. You are a user, let's say, and you are asking some question, and that question now goes to the same embedding API that you have used in the beginning, and it does the embedding. And now that vector, you go into the vector database and you sort that. That is when the indexing helps, because let's say that you have millions of vector embeddings. It's difficult to sort into the embedding. You have index, and different vector databases does their own trick behind the scene to do fast querying and providing you the right answer, because whatever you sort into the vector database, you get the top k retrieval, right? So now I can go to this last piece here, because you get the top, let's say you have top 3, top 10, right? You get the top 3, let's say example, retrieved information, and that information, after you get the vectors, then you get the context, and that is when you pass into the LLMs, and then it synthesize the answer for us, right? So meaning that the main part here is the vector databases and the embedding models, how they are being utilized. There are different pieces here and there, and I hope now you get little bit more idea how to get into this. Now the second half of the video, let me go to my GitHub. I have created one video before about LLM resources, and this is the GitHub repository, LLM resources. I'm expanding this repository as I progress, and now I think I will be putting more effort into this, because there is some really good content here, and I just want to point to this making RAG work properly part, right? So here, these are the things which I just explained you. So you need to clean the documents, choosing the right parsing, and also there is llama parse. I created the video earlier. You can refer to the llama parse if you are worried about, okay, what document loader you should use. So llama parse takes into your things and provide you the clean document. That is also one option. There is unstructured, which helps you to clean your document, right? And better chunking strategies, I just said you that. Choosing right embedding model, choosing the right vector store, parsing instructions and re-ranking things also, and choosing the right large language models. And also I didn't cover that, but yeah, LLMs also, which LLMs to pass, right? People are comparing, let's say, GPT-4 with some open source models, which is not there at the moment, right? Yeah, there are open source models, but still we cannot compare those two things. But there are different models appearing in the market, so you can just test between those models. I will also show you the link here how to do that, right? So for that, here are some of the links. I highly suggest you to go through this, and also if you want to know if I add more things, you can just start or watch this repository also. I'll just show you all those things here, First, there is this chunk visualizer, right? Let me just open this. This is in the Hugging Face spaces. As you can see here, if you don't know what is chunk visualizer or how to do the chunking things in langchain, this is the example of langchain again. So this is the document you passed, and here there is the example of character text splitter or recursive character text splitter. Let's just check the character text splitter. And now, as you can see here, this is the document, how it is being chunked. Let's say split into different chunks. So there is the 200 chunk length. You can play around with this number, and there is the overlap, there is 10. So if you highlight or hover on top of this, it will show you which part of that is being splitted into different chunks. So you get the idea, okay, how does the chunking things work in the langchain. These kind of things, it seems simple, but if you know the basics of these kind of things, it helps you to do the better chunking, let's say in that way. And let me go back. There is the tokenizer from OpenAI. So there are different tools already available for you. Why I want to show you this is because I hope you have heard about the tokenization, oats, how many oats has how many tokens and so on, right? Let me just say that, okay, OpenAI is not open anymore, and I will pass 2024 and dot. Now, as you can see, I passed this sentence here, and this sentence has 11 tokens, and there are 33 characters. But if you go here, how many words we have? We have 1, 2, 3, 4, 5, 6. But there are 11 tokens and 33 characters. It might be confusing in the beginning how these things work, right? As you can see here, open is different token, AI is different token, and you can see any more, and there is comma, that is different token. 2024, even a whole year, is not a one token. So 202 is one token, and then 4 is another token, and so on, right? And the base, let's say the rule of thumb here is also a helpful rule of thumb, is that one token generally correspond to approximate 4 characters of text. And then here you can see 100 tokens, approximately 75 words. So I hope if you haven't been through this visualizer, I hope it's a good place where you can just go here and play around with this and see, okay, how the tokens are being created, right? And then next there is this embedding things. I'm going step by step when I explain you the RAG pipeline. So now let's say that you want to choose the best embedding models, and now here is the thing called MTEB leaderboard in Hugging Face space. From here you can choose what is the best embedding model, right? What is the size of the embedding models? Okay, what is the dimensions, which I was referring you before? What is the maximum number of tokens? And all the different things are being explained here. You can just go here. You can see, if you go here, there is text embedding 3 large from OpenAI, and even better are on the leaderboard here, right? So there is this Mistral 7B instruct, there is SFR embedding Mistral, and so on. And this keeps on changing. This is the overall, but you can even go with your specific use case. Let's say you are doing some re-ranking things, right? As you can see here, in re-ranking, you can just go ahead and choose these models and then just try and see which one performs the best, right? And then also, what is vector database and how does it work, right? This is really good. Let's say the blog post from Pinecone, which explains, right? Roy, I hope I'm pronouncing correctly, Schweitzer, developer advocate from Pinecone, he has explained really good what is vector database and how does it work, with the real example also here, right? You can just go here and see if you are new to vector databases also. And also by the same guy, there is this chunking strategies for LLM applications. He has also explained here how you can do the chunking things, right? So having this kind of understanding also helps a lot. Okay, then next is the OpenLLM leaderboard, right? You can just go ahead and see in the Hugging Face, okay, what is the OpenLLM leaderboard things. For some reason, it is taking some time to load, but you get the idea that from here you can go and see, okay, what is the OpenLLM leaderboard models, and just play around with it, right? And the next one, this is the most important one. This is Chatbot Arena benchmarking LLM in the wild, right? There are many things here. There is the Arena battle, where you just ask question, you don't know which model it is, and it provides the answer, and you know after giving thumbs up or thumbs down which model is it. Let me just ask it, what is OpenAI, just example. This is just a random example. You just go through this and see, okay, which one performs the best. I'm not going through and reading the text here right now, but you see that it is providing some random things here. Now I don't know which model it is, right? Once it provides the answer, it will ask here, okay, A is better, B is better, it's a tie, or both are bad. Let's say I want to give B is better, right? If I do this, what it is? Okay, this is Cloud A3 Sonnet, and this is GPT-4 1106. I didn't read the document, by the way. I just want to show you that this is how you can see, okay, which one performs the better without knowing in your subconscious mind that, okay, which model you are using. This helps a lot to find okay, how the model behaves, right? So this is one example, and if you want to know already the models, here is the side-by-side things. Just choose the model from here, choose the model from here, write the prompt, see the answer. And you can even do the direct chat here. There is the vision direct chat. You can even do with the vision, let's say, image models here. There is the leaderboard. This is the leaderboard for the LLMs. That was before I showed you about the embedding models, and then there was open LLMs, and now this is the LLM. So there are model 73, there is GPT-4 1106 preview on the top. There is second one is 013525 preview. There is Cloud A3 Opus, and so on. And this keeps changing. So way to track the things, yeah, just bookmark these things, come here and check which model performs the best and use the models in your application. That's what you can do, right? There are other important documents or blog posts now, and this blog post which uses llamaindex code behind the scene, and the blog post by Wenji is, let's say, golden blog post here. So tubel RAG pain points and proposed solution, because there was a paper called 7 failure points when engineering a RAG system. Based on that, they have provided the answer, not only 7, but they have provided pain points, 12 different pain points, and how you can achieve that using llamaindex, right? Just go through this document. It's a really, really good document if you want to create solid RAG applications. I can just go through. There is missing content, miss the top rank documents, not in the context, not extracted, wrong format, incorrect specificity, incomplete, data ingestion scalability, structured data QA, data extraction from complex PDFs, fallback models, and LLM security. So now by just going through the headings, you know these are the things that we care when we create our RAG applications, right? So there is already a solution for this. You can just go through this blog post, and there is also the code provided into it. I might even create some videos related to some of the topics here, because that's the main thing that you learn by doing. So yeah, just go through this, implement yourself using the llamaindex code, and see how your RAG application performs. It might performs better, right? And the next one is optimizing RAG with hybrid sorts and re-ranking. By the way, this is also already in this tubel RAG pain points, but these 3 blog posts, I liked it because it has explained really good way, let's say, in that way. Improving RAG performance from knowledge graphs, and then enhancing RAG with multi-agent system. So if I just click this one, this is the blog post in the vector hub. So optimizing RAG with hybrid sorts and re-ranking. I hope you know re-ranking things, but yeah, just go through this. It has explained with diagrams, okay, how does it work, and also there is langchain examples with it. What do you need more? There is someone explaining you things with the code also as an example. So thank you for all the people who are writing the blog post with clear explanations as well as the code. So yeah, improving RAG performance with knowledge graphs. So yeah, just go through this. And there is enhancing RAG with a multi-agent system. So there is agents also that you can do, right? So yeah, there is also things, and there is also the code, as I said you here. It is using the AutoGen agents. So yeah, this is just a simple video I just wanted to create. I think it already went over 20 minutes or approx 20 minutes, but it doesn't matter how long it went. But now I hope you get somehow the understanding how to make your RAG applications better, because creating a simple RAG application is just copying the code from someone and then running and say, okay, voila, there is the code running, you have a RAG applications, and then you start seeing, okay, why don't it perform better? Yeah, it didn't perform better because when you use the normal vanilla RAG applications, there are so many things to be tweaked, and it is not tweaked. Similar to when you train machine learning models, if you just use the default parameters, it doesn't perform well for all the applications. You need to modify the parameters based on your application. Similar to this in LLMs also. In order to have the best answer for your applications, you need to tweak between different parameters. You need to find what is the pain points, what is the thing that is causing the problem for your RAG applications to perform not better, let's say in that way. So yeah, just follow some of the approaches and give, but don't try to fulfill or not fulfill, but don't try to implement all the solutions at once. Then you don't know which one was causing the issue. Just go step by step. Go with the first part, okay, chunkings, use some of the existing provider chunkings, and so on and so on. Right now, I hope you get the idea how to improve things. If you like this kind of videos, please let me know in the comment section. I will create more of these knowledge sharing kind of things in the future videos also. If you like the video, give thumbs up. If you haven't subscribed yet, please do so. It motivates me to create the good content in the future also. So yeah, thank you for watching and see you in the next video.